Hello everybody, welcome to the homework help video for 532. We're going to be looking at problems 101 through 110. So all of them that will eventually be due. And so we'll begin with 101. It says for each table below, find the missing entry and write an equation. And so when we look at this one, in the first one we've got the month and the population. So it's pretty easy to see here that as we go, we're either adding by 6 or multiplying by 4. So we can quickly see 8 plus 6 is not going to be 32. So what we have going on here is where we're multiplying each one by 4. So you'll take 32 times 4, 128, 128 times 4, 512. Really quick, you can see how fast it's growing. That's why we call this exponential growth. 2048 times 4, 8192. And then the one in part B isn't as obvious, whereas what we've been able to do up till now is we've been able to look at something and pretty much tell what it's going to be. Like we did in A, we just knew it was going to be times 4. The relationship isn't as clear when we're trying to get from 5 to 6 and then from 6 to 7.2. For this one, it's also going to be geometric, and so we're looking for what times 5 is going to equal 6. Just like what we were doing before, we would take the one previous, multiply it by something, and that would give us the next term. So we're looking at 5 times what is going to be equal to 6. And so when we do 6 divided by 5, we get 1.2. X is equal to 1.2. So my guess is what we're actually multiplying by each time is 1.2. But we can double check to see if that is the case, and we should. So what is 6 times what will be equal to 7.2? So if we divide both sides by 6, 7.2 divided by 6 gives me 1.2. And so what we need to do is 7.2 times 2, times 1.2 is going to be 8.64. Then we do 8.64 times 1.2, and we're going to start to get some hairy decimals. So there's definitely not enough space for me to write them all out. 368. Then we multiply that by 1.2, which is going to give us 12.4416. And then multiply again by 1.2, 14.92992. So the trick for B is being able to find out what our multiplier is by taking our previous term and dividing it by that next term. So if we know T of n plus 1 divided by T of n. So for example, T of 2 divided by T of 1, which was our 7.2, our 6 divided by 5, my bad, will give us whatever our multiplier is. And that's how we figure out 101. So we're going to move on. Looking at 102. So in 102, it asks us to convert each percent increase or decrease into a multiplier. So what would we need to multiply each time? This isn't too bad. First, we could think about what these are as decimals. So 3% is 0.03, 25% is 0.25, 13 is going to be 1.3, or 0.13, and then 2.08 would be 0.0208. And they're going to tell us what they want to do. Increase means that we're going to have 1 plus 0.03, which will give us 1.03. A decrease means we'll do 1 minus 0.25, which will give me 0.75. We've got another decrease, so we're subtracting, which will give us 0.87. And then again an increase, so 1 plus 0.0208 is simply 1.0208. And so what we should see here is that When we have an increase, our number is greater than 1. And again, another increase. So we have a number that is greater than 1. And when we decrease, our number is less than 1. Our number is going to be less than 1. All right, moving on to 103. 103, we've got a nice big word problem. Lots of stuff to sort out through, but hopefully we can figure out what we're looking for. So it says, Mr. C is such a mean teacher. The next time that Matthias gets into trouble, Mr. C has designed a special detention for him. So Matthias will have to go out in the hall and stand exactly 100 meters away from the exit and pause for a minute. Then he is allowed to walk exactly halfway to the door and pause for another minute. Then he can walk the exact half of the remaining distance to the door. And so what we're really looking at, it says, so unless he breaks the rules and goes more than halfway every minute by a tiny amount, when can Matthias leave? Prove your answer using multiple representations. Oh boy. So with this problem this is a classic problem where what we realize is that we're actually going to reach an asymptote on the graph. What that means is a number that we'll get really, really close to but never touch. So what we're doing here is we could create a table of our n's and our t of n's. We know that when he starts, he's 100 meters away, and then the next time he'll be half the distance, so times 0.5. So the next time he'll be 50 meters away. The second time, again, we're going to times by 0.5. He'll be 25. Then again, times by 1/2. So 25 times 0.5 is 12.5. Times 1/2. And we can keep doing this over and over and over and over again. And they want you to see if you can find out a time when we'll be able to do that. What I would like to show you guys on the graphing calculator is that we can plug in our original equation. I'm going to put in our explicit equation. Our starting value is 100, and then we're multiplying by 1/2, or 1 divided by 2, each time. I'm going to have my table start at 0, because it wouldn't make sense to start at anything negative. And, oops, I hit the graph. I meant to hit the table. We can see, you've got my little table in red that you can hopefully see. Oops, oh, goodness. There we go. When we look, we've got 0, 100. Oh, I did something wrong. 100 times 1/2. I wrote times x, and I should be writing to the x. So a little bit of notation problem there. This should be caret key to the x. Now my table should work better. Hooray! Now it looks exactly the same. At 0, it's 100. At 1, it's 50. And you'll notice that as we scroll down, we can see by the 10th time that he's taken the step forward, we're already at 0.097. And you'll notice that these numbers are going to get incredibly small. But we're never, ever going to reach 0. What they want you to see, or kind of be thinking about in your mind, is that, is there a number we could divide by in order to get 0? So if we start out at 100, can we divide anything by 100 and give us 0? And what you'll notice is there's no number that we can take and divide by, nothing that we can plug in. Because the only number that would work is if we had 0 over 1. And we did 1 times 100 and x times 0. And what we get when we do that is 0 times x is equal to 100 times 1. So now 0 is equal to 100, which is a false statement. So there's no value for x that will ever guarantee that situation. So we could have shown it graphically, we could have shown it by looking at our table, or setting up that proportion. That one's not a big one for you. It's a good thought process to go through, but it's not something that you'll see on like a quiz or a test. In 104, it asks us to simplify each expression. This is similar ones that you guys saw on your quiz, good refreshers, definitely types of problems you'll see on the ACT, and when we look back at whenever you take a test that challenges your basic math skills. So with this one, we're really just multiplying the two together. We've got 2 times m to the third times 4 times m squared. This is really 2 times m times m times m times 4 times m times m. What we have then, 2 times 4 is 8 times m and then to the fifth. So A is 8 times m to the fifth. In B, we're doing a division problem. Now here, we're not subtracting away that 3. This is still 6 divided by 3, which we know to be 2. So don't subtract. That's only when we're looking at exponents. When we're looking at regular numbers, we still follow our basic rules. So we have 6, and then we've got 5 y's on top and 2 y's on the bottom. So what happens is if we were to rewrite this, we have 6 times y times y times y times y times y over 3 times y times y. This will become a 1. This will become a 1 because y divided by y is 1. And then we know that up here, this will become a 2, and this will become a 1 when we take out what they have in common. And so what we're really left with is 2y cubed. In part C, same exact thing. The only thing that's really different is that you've got a -4 and a 6. Remember, that's really just -4 divided by 6, which we know simplifies to -2 over 3. And then you had y squared over y to the fifth. What we have here is we've got 2 y's up top, so those are going to go away, and we'll have 3 left in the bottom. So your final answer should be -2 over 3y cubed. And then in D, we have that whole quantity cubed. Some people were really good at spotting out that this is really just 2x squared times -2x squared times -2x squared. What you then have is -2 times -2 times -2 times x squared times x squared times x squared. This is going to give us a -8x, and then we're going to add these together. So we've got 2, 4, 6 total x's. So our final answer for D is -8x to the 6th. All right, moving on. In 105, it says for the problem, refer to the sequences graphed below. Identify each sequence as arithmetic, geometric, or neither. And if it is arithmetic or geometric, describe the sequence generator. So what they really want us to be able to do is look at these problems and determine what's going to give it. What is going to be the thing that they have in common, that generator. We can see that. I love that they've kept them discrete. We just have the points right here. This is the point 0, 15. And then this is the point 1, looks like 1, 2, 3, 4, 13. And then we have the point 2, 10. Then 3, 7. Whoops. Make sure I did that right. 10, 11, 12, 13, 14, 15. So this is at 13. Oh, that one was at 0, 16. That's why I messed that one up. Our first one was at 0, 16. And so what we can really do is think about if we were to list this as a sequence. I'm going to write it off to the side. We've got 16, 13, 10. Well, that is a 10 and not a 16. Seven, dot, 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 dot. And so we can see that each time we're going to be adding -3, adding -3, adding -3. So we have an arithmetic sequence, and our generator is plus -3. B, if you guys remember the parabolas, there's no pattern. There's a pattern that it's following or a rule that it has, but because we have this increasing then decreasing at that kind of rate, we know that this one is neither. And in 3, probably the most difficult part about number 3 is looking for that generator. We have a good guess that we're looking at something geometric, but we really now need to be able to prove why it's geometric. So with this one, see if I can scroll over a little bit. Nope. We're going to do what we did in number 1, where we're going to pick our points. We again have the point starting at 0, 16. Our next one is at 1, 6. And we have 2, 4. And we're interested in seeing how that one's going down. So if we were to list it as a sequence, 16, and then, whoops, that is not a 6. That's at 5, 6, 7, 8. My bad. That's 1 to 8. And then 4, and the next one is 2, and then it goes on. We might be able to see that what we're doing every time is we're multiplying by 1/2. We're dividing by 2, multiplying by 1/2, multiplying by 1/2. One way we can see that is we can take the previous term divided by, or the next term divided by the previous. So 8 over 16, which simplifies to 1/2. So we know we have a geometric sequence, and our generator is times 1/2. All right, moving on to 106. It says, read the math notes box in this lesson for information about an alternative notation sequence and write the first 5 terms. All right, so with this one, we can look back or up to our notes. And it's just another way of finding the recursive. So instead of using t of n or t of 1, they're using a to the 1, and instead of using t of n plus 1, they're using a to the n plus 1. A lot of you guys have been asking, well, why don't we just use s for sequence? Why are we using t of 1? There is some alternative notation, and that's all they really want you to see there. So let's go back to 106. All right. And find the first 5 terms of these sequences. Well, in A is a way of stating an explicit formula. What they're really telling you here is that t of n is equal to 2n minus 5. So in order to find our first 5 terms, the first one we want to find is when we plug in 1, when we plug in 2, when we plug in 3, 4, and 5. Our first, second, third, fourth, and fifth. So for example, t of 1 is equal to 2 times 1 minus 5, which is going to be -3. T of 2 is going to be equal to 2 times 2 minus 5, so that's 4 minus 5, which is -1. And then we can see that we're really adding 2 each time, so this will be a +1, +3, and then +5. So A is looking at an explicit equation, alternative notation for explicit. And then in B, we can see we've got 2 parts. We already know what the first term is. The first term has to be 3. And then from there, in order to find the next term, that n plus 1, we need to take our previous term and multiply by -2. So our previous term was 3, so 3 times negative 2, negative 6. Now our previous term is negative 6 times negative 2, positive 12, negative 24, positive 48. So please know that this is nothing different than what we've been doing. It's still explicit and recursive, just with a little bit different notation for you. Just, I guess, to throw you off and confuse you, just to see another way that this notation, sequences are used, but with a different type of notation. 107 asks us to solve each equation. So in this first one, in A, we're going to take and we're going to FOIL it out. So you might want to think about setting up your area squares. We've got x plus 2 and x plus 3. So we'll have x squared, 3x, 2x, and then a 6. And when we simplify, we have x squared plus 5x plus 6 is equal to x squared minus 10. And then I'm going to try and get rid of my x squared, so I'll subtract x squared from both sides. So now I have 5x plus 6 is equal to 10, or is equal to negative 10, pardon me. We'll subtract 6 from both sides. So 5x will be equal to negative 16, and so x will be equal to negative 16 over 5. The other one I'll do is D. If you have any other questions or want to see these ones, please feel free to come in and ask for extra help. I'll do one more. We'll look at D. In D, we've set up a proportion. X plus 1 over 3 is equal to x over 2. Because we have this equal sign, we know that we're able to use our cross multiply and divide. So we'll cross multiply. We have 2 times x plus 1 is equal to 3x. So we have 2x plus 1 is equal to 3x. We'll subtract 2x from both sides. And we know that x is equal to 1. Not so bad once we know what kind of method would best help us solve. All right, moving on, looking at 108. 108, it says, for each sequence defined recursively, write the first 5 terms and then define it explicitly. So we're going to write the sequence out for the first 5 terms and then write our explicit equation. So for this first one, it tells me that the first term is 12, and then I need to subtract 5. So 12 minus 5 is 7, 7 minus 5 is 2, 2 minus 5 is negative 3, 1, 2, 3, 4, and then 3 minus 5 is negative 8. For our explicit, T of n is going to be equal to that thing we're doing over and over and over again. So negative 5n, and then I need to figure out what my 0 term is going to be. So I'm going to take and add 5, which will give me 17. So negative 5n plus 17. Then in B, they tell me that the first number in the sequence is 32. Then I'm going to take that and multiply it by 1/2. So we're going to 32 times 1/2, I believe, is 16. 16 times 1/2 is 8. 8 times 1/2 is 4. 4 times 1/2 is 2. 1, 2, 3, 4, 5. So in this one, what we've been doing is we have to figure out our starting term. So again, we need to get that 0 term. So before we were timesing by 1/2 each time. So now what we're going to do is we are going to divide by 1/2. So 32 divided by 1/2 is 64. Same thing as multiplying it by 2. So we'll get 64 times our multiplier, which we said was 1/2, to the n. And that's how we can find our first 5 terms and then write the explicit equation. You should be feeling really comfortable being able to do problems like this. If you're not, please come in and see me for extra help. And in 109, almost there, 2 problems left. Whew. Multiple choice. Which line below is parallel Oh boy. So we have to think about what it means for something to be parallel. Well, if something is parallel, that means they're going to have the same slope. So I'm looking for an equation that's going to have a slope of -2/3, and then they'll have a different starting value. So let's see. Let's see how we can do this. We have 2x minus 3y is equal to 6. So if I subtract 2x from both sides, oh, that's going to be no good because then I'm going to have to divide by a negative number. So this will turn that one positive. So A is out. Let's try this again. Let's try B. 2x plus 3y is equal to positive 6. So we'll subtract 2x from both sides. 3y is equal to x minus 2x divided by 3, which looks like the winner. Y is now equal to 2 minus 2/3x. So we now have the same slope and a different intercept, so B is the correct answer. And seeing as it says which line, I'm guessing there's only one correct answer for this one. And then our last problem. In 110, it says the graph at the right shows a comparison of the length of several gold chain necklaces. I bet 2 Chainz would be really excited about this question. And their total mass. So we can see the length versus the mass. Write an equation for the best fit, and based on your equation, what would you expect the mass of a 22-inch chain to be? So with this one, we just got some random points, but we do see that we've got some type of linear relationship. We should know that it should be going through 0, 0, because if you do not have a chain, it should not have any mass. So we're really looking for, well, what can we connect through 0, 0? What kind of points look like they'll go through and be a best line of fit? So I tried to dot that. And are there any points that it goes through? Any points that we can kind of approximate on here? Looks like a good point that goes through my line is this one, which looks to be occurring at, this looks like about 14, and this looks like 13, 14, 15. Looks like it's just in between, so that should be 13. So we're looking at the point 13, 14. And then I'm going to use the point 0, 0. So we know that our equation for a line of best fit is if it goes to the point 0, 0, our intercept is at 0. So y is just going to be equal to our slope times x. And we know we'll have the slope of our change in y over our change in x. So my change in y is that I had to go up 14 and then over to the right 13. So my equation is y equals 14 over 13x. You might have a little bit different numbers depending on the point you chose, but as long as we're picking 2 points, finding the slope between the two, and then solving. So then they say, what would you expect for the mass of a 26-inch chain? So mass is a y value. So y is going to be equal to 14 divided by 13 times 26. 14 divided by 13 times 26 is about 28.
Hi, Liza, how are you?
Good, 1 second.
Okay, sure.
So we'll get that y is equal to